Hello. In this video, I would like to show you how to build custom-made plugins for the QAquifolium tool. So essentially, what we call plugins. These are um, a, essentially a way of describing governing equations, controlling the flow or exchange of materials between different blocks in Aquifolium. And the Aquifolium is designed in a way that it allows users to quite easily define their own components so that the program is expandable. So now these these plugins are defined in JSON uh, format. So JSON format is a kind of a data structure that allows object-oriented essentially data to be described in a text file, essentially, or ASCII text file. Um, so let's just start by so what I'm going to do in this example is that I want to just create a very simple plugin for let's say a stormwater pond with some sort of a where that allows the flow out of the pond to be controlled. Um, so at the first stage of the video, I'm gonna just um, create the pond template, and then I'm gonna add basically a connector that represent the wear and the flow rate over the wear. So the first thing I'm gonna do is I've already created this folder um, in so this is called stormwater pond instructional video. You can create a folder in on your hard drive, whether it's Windows or Linux, it doesn't really matter. And then or you can actually use an existing one. Or you can use you can dump all the files in the resources subfolder where the QAquifolium is installed on your machine. So I already have these two icons that I'm going to use, and I'm going to show you how to use them. So I've already, copied them here. All I'm going to do is I will just basically, let's do this. I'm going to initiate my text editor. So this is a text editor that I have here, and this video is going to be a little lengthy. I want to try to minimize the time. So I'm going to use some templates that I already have. You can do the same thing. So first, let me just save this. So what I'm going to do is that I'll save this file in the folder that I just showed you. So basically here, and let's call it pond pond plugin, or you can name it anything you want. This is what I'm going to call it, and then it's going to be a JSON file. So I'm going to add an extension JSON. So now it's basically saved. Now what I'm going to do is I want to just define this object for a pond, and as I'm moving forward to create it, I'm going to explain every line. So the way a JSON file works is that you have these brackets. I mean, you have a main bracket, and every object is defined in a certain way. So this is now you can essentially this is our root, the root of our object, or or the root of our document. You can say you can say something like root. Actually, all the text will go to quotation marks, so you can say root, and then put one colon, and then define everything or not. So it doesn't matter if you don't have that. So I'm going to just remove that, and then we can basically the first thing we want a name for the object that we're going to define. So we're going to actually define this pond object right here underneath this. So what I'm going to do is that I'm going to say the object name is let's say it's a pond, right? And then I'm going to define the properties of the pond right there. So underneath this, I'm going to define the properties of the pond. And so a few things. The first thing is that every object that we define in QAquifolium, it should have a type. The type is either a block, is a link, or a source, or an objective function, or a parameter, right? So in this case, we just want to, pond is represented using a block because we want to perform mass balance inside the pond. Essentially what I'm going to do is, and every single object that we define, we should say what's the type. So the way that's done is we can just write type, and then the type is a block. And every time I want to write another line, I need this comma. So I put a comma. I go to the next one. There's this other thing. There's this other essentially property that we need to define, and that's called type category. So type category is in this case I'm going to call it blocks, and let me explain what that is. Essentially, if I open, let me run QAquifolium right now, so to show you where these things go. So the role of this is the main window of QAquifolium graphical user interface, and you have in the object browser window, we have a number of items here. If I add, let's say, a block right here, let's say I add a catchment. The catchment goes under blocks. So that's the way the program finds out where this should go is essentially based on this type category that we just defined. So type category is blocks. That means that if I have a component that has that type category, whenever I add it, it goes under blocks. Okay, so this allows to make kind of design the way we want the graphical user interface to look like by maybe creating new type categories and things like that, or to organize our objects in a better way, right? I'm going to drag this out of the way. So the next thing we want to have is we want this pond to have an icon, right? So basically we're going to have another property called icon, and the icon, the way it's basically, so the only thing we want for the icon is a file name. So where the icon needs to be taken from. So file name, essentially I have to put it in quotation. File name is going to be, so now I need the full address of the icon to be used. And as I mentioned, we have some icons already saved in this folder that I want to use for saving the template in. And what I'm going to do is that I'm going to use this stormwater pond icon for this object. So what I'm going to do is, let me just click on the properties so that I can copy the address. So I can just copy the address here. I think in Windows you can do it the same way. And then of course the name of the file. So let me get the name of the file from here so that I don't make a mistake in. So it's called stormwaterpond.png in my case. And that's pretty much it. So I go to the next. So the next thing that every single object should have is a name, and the name, the way we basically, this is where is a property that stores the name of our object. Okay, so the name, you can have a pond with any name you want to assign to it. So let's say my pond, or pond 1, or pond 2, or things like that. So now the name is actually pretty standard the way it is, and I'm gonna just copy and paste it from a template that I have, and then I'll go line by line to explain. So the way it is, let me format this in a better way so it's better understandable. So we have a name. The name has these 4 properties. um, and each, from now on, each property that I define should have some, basically each property of pond that I define should have some you know specs or some parameters that I need to define, and depending on what type of properties I'm talking about, um, those basically specifications may be different, um, or some additional ones may be needed, which I'm gonna walk you through. So the first thing is that we have this description name, and that is what is shown in the property window. So if I go back to my graphical user interface here, I'm going to bring it here, so you can see that we have essentially so if I scroll down, I'm going to see the name. So we have this name, and you see that it's a capital letter name, and then there's a name of object, and I can change that. But the name, so the thing that you see here, that's what is written in the description, basically description line right there. So you can assign some simple names to different properties. Let's say AB, or I don't know, something hyphenized or anything, and then you can have a description that is more sort of descriptive, so that your user, when you use it, you can see more information here in the property column right there. So okay, let me move this out. Then the second thing is type, which is a string. Of course, the name is a string, and that's important. So when you want to enter the name, you basically enter a string as opposed to a date or a file that you need to pick, a file name that you need to pick using the directory browser, or for example, a number, and so on. So that's about the type. The the next item is something called ask user. So we may have some properties that we don't want to ask from the user to enter. Like there's a constant that is has always the same value, or it's something is a property that is basically calculated internally by the program dynamically during the simulation, and we don't necessarily want to ask the user to provide the value of it. But in this case, we want the user to be allowed to enter the name of each pond that is added to the system. So basically, we set this ask user to be true. If you don't have this line at all, the default is false. So if I define a property that doesn't have this ask user line, the properties will not show up in the property window when you click or when you select the object. So. And then the last one is a delegate. So the delegate is here when I want to enter the name. It's basically a string delegate. So essentially, you can type basically you have a way of typing strings. Now, if you can have different delegates. For example, you can have, I don't know, a box that allows you to enter dates, okay, or numeric values, or allows you to click and then select a file in case you want to add some, let's say, time series data, things like that to the model. So let's say I'm going to call this, for example, my catchment in this case, and so the name now is changed to my catchment, and if I click here, you'll see that the name is changed to my catchment. So that's about the name. The next basically property that we want our pond to have is a storage. So storage is the amount of water that is in the pond at any given time, right? So I'm gonna basically type these property, the specification of this property line by line. So it's actually, first of all, the name is a storage. Okay, so I got to do the colon, and then I open a bracket. So now I'm going to describe this property, this quantity storage. So let's go line. So the first thing is, of course, I can have a I can have a description. Here's what I'm gonna do for the description. What I'm gonna do is, because I want this storage to serve two purposes. One is that I want to allow it to basically, so I want the user to be able to enter the initial storage in the pond. Um Also, when I run the model, the storage is updated automatically based on water balance, essentially in this case. So the description, I'm going to say here initial storage, and the reason why I'm doing that is I want the user to see in the property window to see that the number that they enter is going to serve as the initial storage. So I'm going to say that the description is initial storage, and then other things. So let's say type. In this case, type is a. So it's basically the type is something called balance. Okay. So essentially, what I'm saying is I want the storage to be dynamically calculated by performing mass balance. Okay. Now, whenever I say that the type is balance, I have to say the balance is done based on what. Okay. So what is our inflow and outflow, or influx or outflux of that quantity? Because Aquifolium allows multiple variables to be considered as balance, and for each of these uh, quantities, a different quantity may control the balance of that. So for example, we may want to do a balance of water and energy, and maybe a certain kind of contaminant, right? So each of them have different processes controlling their balance. So in this case, what I'm gonna say is, so basically that thing is indicated by this keyword called flow. So the flow that controls the balance of storage, we're gonna call it flow. Okay, so this means that if I define any connectors that will connect a pond to another pond, that connector should have an equation that basically calculates the flow. Okay, so we're gonna go through that when we define the connector for example, a where or anything else. Next thing that I need to have for the case of storage is another property called inflow. So basically as in addition to the inflows and outflows through the connectors, you may have some sources and sinks. For example, we may have, I don't know, in the case of the pond, we may have evapotranspiration or evaporation in this case, or we may have direct precipitation into the pond, and we want to be able to somehow introduce that. So what I'm going to call the inflow is, in this case, I'm going to assume that the only direct inflow to the system can be precipitation. So I'm going to say precipitation. Okay. Then the next thing is, so again, I want the user to be able to enter the initial storage to the system. So I'm going to have this ask user, which I'm going to copy from here. I'm going to say it's true. So the ask user is true. The delegate is something called the unit box, even though it doesn't allow you to actually enter the unit. So unit box, I'm sorry, I gotta do it this way. So delegate, and please note that it's very important to enter the keywords with the same format. So it's basically all lowercase, because actually, Aquifolium does in Aquifolium the lowercase uppercase situation of the keywords matter. So now the other thing I want to add, which essentially explains pretty much most of the um, specifications that we can enter um for each for basically all the properties that we can define is basically there's this thing called estimate. So do we need the user to be able to um consider initial storage as a parameter, as an unknown parameter, to be able to, and then be able to estimate its value, for example, for optimization purpose or other things. And I'm going to make that true in this case, even though it's not going to affect our results that much. There's one thing that I forgot to add, and that is basically when I have a balance type, I should I should also, there's this thing that I have to add, and basically I say, perform mass balance in order to calculate this thing. And basically the way to do that is by just writing this mass balance keyword and then setting it to true. So I'm going to add that right there, and that's it. So now we have this quantity storage. I haven't really talked about how the quantity storage is essentially simulated, or is basically computed during the simulation. I'm going to talk about those things later on. Now, okay. So now, one thing I want the pond to do, that stormwater pond to do for me at this, and which is at this time important, is I want to be able to essentially calculate the hydraulic head as a function of storage. My stormwater pond should have a hydraulic head, because when I define my connector, which in this case is a weir, going out of the stormwater pond, the the flow is calculated based on the hydraulic head in the stormwater pond, right? So what I'm going to do is, and this is what I'm going to do. I'm going to show you something. So I'm going to assume a very, very simple model for predicting the storage as a function of head, which I have to inverse it. So essentially what I'm going to assume is that I'm going to use this basically rating curve that you see on the screen. So S is equal to alpha d to the power beta. Now in this case, S is the storage in the pond, D is the water depth, and then alpha and beta are just, let's say, just some empirical coefficients and exponent, right? And then what I have to provide is basically the opposite. I need to essentially calculate the water depth based on the storage, and then of course the hydraulic head is going to be the water depth plus the bottom elevation of the pond, right? So or a certain datum that I consider for the pond, right? Because you may define the elevations, maybe, I don't know, based on sea level and so on, and we may want to basically express hydraulic heads based on the sea level or any other datum that you want to consider, and we need to provide that bottom elevation of the pond, right? So essentially what we do is, if you have we're going to calculate the depth based on this equation, which is the inverse of equation 2. So equation 3 is just simply the inverse of equation 2. So equation 3 gives us the depth of water as a function of the storage using these empirical parameters. So what I'm going to do now is that I will just define two parameters, alpha and beta, somehow. And since you know what things mean, I'm just going to copy it from somewhere that I have it already, and then I'm going to explain the additional, specifications of that quantity that I haven't, explained already under storage. So first I'm going to define this property alpha. I guess I'm going to do this, and then let's just no. Okay, that's fine. It's it has to go probably here to be in the same. So for alpha, I don't need this unit, by the way. So here are the properties that are assigned to this quantity alpha. So first of all, this type is a value, right? It's a value. That what that means is that we actually enter the value. The user enters the value of alpha. The alpha is not dynamically calculated. It's just a value that is provided by the user. And so that's a type. The type is a value. And if you have a description, the description is, you can put anything you want in the description. You can make it as descriptive as you want. Now in this case, this is what I put in. The coefficient alpha is the doesn't make any sense. So is the oh yeah, in the rating curve. This. So basically, what's the coefficient alpha in the rating curve, S is equal to alpha times d to the power beta, right? So what we mean is basically whatever value you enter here, it's going to go here in this equation. And this is just a description. I mean, it's not going to affect the how the program interpret what you put in. So you can write anything as anything you want. So second item is, of course, ask user. We want it to be true because we want the user to be able to enter alpha. The delegate is again unit box. So what that means is the user is going to enter a numerical value. We want to be able to treat alpha as a parameter to be estimated, for example, for the purpose of optimization or calibration and so forth. The other thing that we have in this case that we didn't have in the case of storage, probably we should have had, is a criteria. So what I'm going to do is that I'm going to add a criteria because I don't want the user to be able to enter, for example, an alpha value that is 0 or is a negative number, or I may have other criteria as well. So what the criteria is we say alpha greater than 0. So what that means is basically the alpha value, if the user enters an alpha value that is smaller or equal to 0, it's not going to be accepted, and the user will receive a warning message that reads alpha coefficient must be positive. You can just put, so this is the warning message that the user will get. In fact, I can do similar thing for maybe storage as well, because I don't want the user to enter a negative number for storage. So basically the criteria for, I need a comma here, and the criteria for storage is going to be storage. This has to be greater than equal 0 because it can be equal to, and then I'm gonna say storage must be positive. Oh yeah, storage should not be a negative number, or let's say cannot be. And you know what, this is what I'm not sure about that, so let's do this thing. So I'm going to say storage is greater than minus 0.000001, which is effectively means that 0 is accepted, but it can't be negative. Okay. Okay, next thing, I'm going to do beta. Beta is going to be pretty similar to alpha. So what I'm going to do is that I'm just copying this one, and then I will just paste it over here, and then I'm going to call this, let's say, the beta description. Let's say I'm going to just change the description to the exponent beta in the rating curve s equal to alpha times d to the power beta, which is correct. And then of course the criteria, I have to do it again. I want beta to be larger than 0, so I'm going to say beta, it's an exponent, right? So I'm going to put the exponent here, and that's pretty much it. Next thing is, okay, I want to say to the program to calculate the water depth dynamically using this expression right here. So expression 3 that you see, right? So the next quantity that I'm going to define is depth, right? Now let me tell you something. We don't necessarily have to define water depth. We can just go directly to hydraulic head, and that will make the program to run a little faster because this intermediate variable doesn't have to be calculated. But I'm gonna just put it. I think it's useful to have that depth. And the other thing is when I put this variable depth in, I can see the outputs for depth. So basically, I'm going to define this depth quantity and let's see what to add to. So first of all, the type in this case, for the case of depth, is an expression, right? So we want the depth to be calculated based on other state variables and parameters of these component pond, right? Then the next thing is so now it's an expression. Now I have to say what is our expression? What expression should be used? So basically, the expression is, it looks, as you can see right there, is storage. I'm going to put that in a parentheses, right? Storage divided by alpha to the power 1 divided by beta. And that's all we want. Okay. So now as the simulation is run, for any pond that we have in the system, the water depth is calculated based on this equation. And you can basically, as you can imagine, you can come up with your own expressions for calculating the depth of the water in a pond that is maybe more accurate or more realistic than what we have here. But I want to keep this example as simple as possible. Then what else do we need for depth? So again, we need description. We better have this description. So the description is, let's say, water depth, right? Then now ask user. We want to. I mean, we don't actually have to put in. I mean, by default, ask user is false. So if you don't put this line, it's going to be considered that the ask user is false. So basically, we don't want the user to enter depth because we allow the user to enter the initial storage. So there's no need to. I mean, we can't really enter both of them. Or allow the user to enter both of them. So the depth is not something that will be provided by the user during the runtime, but it's just calculated dynamically based on other state variables, essentially. And of course, then the delegate is, we don't need that. And then, but then I want to add this one thing called include in output. Okay, so include in output keyword says that I want the values of depth that are produced or calculated during the runtime to be shown in my output. So if I right click on my, after I run the simulation, if I right click on my on the object in the GUI, I can see the depth, what was the value of the depth during the simulation time, right? So so include in output, I'm going to make it true, and that's pretty much it for the depth, right? So I guess that should be all. Now next thing I want to do is basically I want to also be able to provide the bottom elevation of the tank so that I can calculate the hydraulic head, right? So I'm going to say bottom, another quantity, let's call it bottom elevation. Then so now here I describe what bottom elevation is and how to deal with it. So you know what, actually, because of the fact that this bottom elevation is something that is entered by the user, I expect to be pretty much, I can use this parameter beta. So I'm going to just copy this, paste it right there, right? And so then change some stuff. So basically it's bottom elevation, the type is value, that's correct. So here I can just type the description. I'm going to just say bottom elevation of the tank, or you may of the pond. So you may enter, you know, better, more descriptive descriptions. I don't know, let's say the, you know, lowest elevation of the bottom of the pond, or anything you want. So anyways, then it's ask user is true, the delegate is unit box, estimate, we might want to estimate it or not, depends on you. And then of course there's no criteria, because the bottom elevation can be positive, can be negative, so I can just get rid of the criteria. And I have to be sure to basically not have a comma for my last item. There's a good chance that we make mistakes here, and but when you load the plugin through QAquifolium, it's going to tell you where the errors are, and you can go back and fix them. So so that's it. And then the last step is to calculate the head, right? So I'm going to say head, and so the head is obviously, it's an expression, right? So the type is expression. It's the expression to calculate the type is essentially depth plus bottom elevation, right? And let's say the description is hydraulic head. Let's call it hydraulic head. We don't want the user to provide the head, obviously, so ask user is going to be false, even though we didn't really need this. And we don't need a delegate, but we want to include it in the output. So the head, the hydraulic heads that are calculated in output, we want it to be shown in our output. So I'm going to say true, and that's pretty much it. So we have this one. The other 4 properties that I'm going to put in are essentially default. Every block object is going to must have those 4 properties exactly the same way as I'm going to basically type in. But I'm not going to go through and type it. I'm just going to copy it and paste it from another template that I've created, and you can do the same thing and just go ahead and copy and paste. Okay, this came out not very pretty, so we just format it a little bit. Maybe good enough. Okay, not as good as I wanted. I mean, it's not formatted properly, but by the way, there are tools, there are web tools and so on that allows you to, you know, create basically JSON files over the web, or maybe others, and will basically, you know, if you make a mistake, or I don't know, the format syntax is not correct or so on, you get some warnings, and those are probably more helpful than what I'm using right here. Okay, so anyways, I don't want to spend a lot of time, you know, formatting this, so I'm just gonna keep it the way it is. And then so let me go and explain what these things are. So I actually added 4 properties: x, y, width, and height, right? And you can see that, you know, the type is a value, so we allow basically it's something that the user enters. The description is just x. You can put something else. The default value is, I've just put in 900, and then we made the ask user true, and the delegate is a unit box. This is the same for all of them except for this default value. So what it does, these are the uh, essentially graphic properties. So how you want this object to be shown on the screen when you're running the GUI. So okay, X and Y keeps um, store the location of the rectangle that are representative of that block. So the default value, by the way, you can have for all these things, we can have a default value. So maybe a good idea to now, let's say, add a default value for beta. Okay, so basically what I can do is that I can say default, and what the default is when you create a pond object, the program will automatically assign a value of 2 to beta, and then of course you can go and change that, but that's what I mean, anytime you create a new pond, the value of beta coefficient is going to be equal to 2 initially. So now what we want is basically what this block says is that if I create a pond, it's going to put it in this coordinate 900 and 900 on the screen, and the width and height of the object is going to be 200 and 200. And every block that we define should have all these properties, right? These are just like, it's just like any other parameter that we provide, but these are special things that every single object should have in order to be able to basically shown on the screen, right? So essentially what I think is that I'm done with this, the pond block, and I can now go and test it, and then in the next lecture I'm going to explain how to create a connector representing the outflow from the pond, which is very important. If I want to use this pond in a kind of simulation purpose, I need to have that connector as well, right? So I'm going to save this, and I'm going to now go and try to see if I can load this plugin, and if everything goes fine, there's a good chance that I might have made mistakes and things like that. So, which we're going to find out. Okay, so what I'm going to do now is that I wanna just test this component that I just created to see if it works the way it's expected, if I have any errors or anything. I mean, we can essentially add other components down here. So we have this. I mean, our template right now only has one component that is a pond. I'm not gonna, because I want to keep the video, as short as possible. I'm not gonna add the connector here in this file at this time. I'm gonna do that in the next video. So I'm just gonna test this to see if it works, and I don't expect this component at this stage to do anything interesting because I can't really connect it to other components and so on. I'm gonna need the connector. So you're not gonna see any dynamics, but we still can test it and make sure that it works. By the way, there's one item that I essentially could add and I didn't, and it will be helpful if I do, even though the template is gonna work without it. Okay, so what that is actually it's description. So basically I can just add a description here. So I'm going to show you where the description shows up, and then I'm going to put something a little more descriptive than just simply pond, which is the name of the object, or the name of the class of objects. So I'm going to put, let's say, I don't know, stormwater pond, right? You can add other things. You can maybe mention something about whether the fact that, for example, the stormwater pond's head is controlled based on a rating curve or anything like that. So anyways, so I have this one, and then now what I'm going to do is that I will just try to load this template to see if it works. So I'm just going to run my QAquifolium GUI, and the QAquifolium GUI comes with, basically, if you look, the first thing you see is that it says template was successfully loaded from this one. So this is essentially our default template. So whenever you run QAquifolium, it's gonna uh, 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 open a default template which contains these objects that you see up there, and then we can add to it. So what I'm going to do is that I will just go to plugin, sorry, preferences, and then I'm going to click on add plugin, and then I'll try to load the JSON file that I just created, right? So basically you go to, I mean, I saved it in stormwater pond instructional video, and I have the pond plugin, and I'm going to open it. And as you can see, you have this stormwater pond shows up here. And the only reason that we put this description there, that it was essentially, if I move my mouse cursor over this object, you're going to see the description, which is more descriptive. So if I didn't have it, it would still work, but then instead of seeing the stormwater pond description, we would see this pond, which was the name of the object, so we could see this one. Anyways, so now, in order to do that, in order to use this object and test it, what I'm going to do is I'm going to click on it. So we're going to have a pond here. I can change the name and so forth, but let's just now I can assign the properties that I want. So as you can see, we assign this default value to default value for the exponent beta, which had a value of 2, so that by default the value 2 is assigned to the exponent, and I'm going to keep it that way. I mean, you can change it or not, but so then we're going to enter, let's say for alpha, I'm just going to say, let's say alpha for this this pond is 5. Okay, let's say I have some experimental data or bathymeter data. I don't know that. And then we have, let's say the bottom elevation of the pond is 10 meters from the sea level. I mean, just, I don't know, or maybe anything else. And I'm going to put some initial storage. So the initial storage, let's say we have 100 cubic meters of water initially in our pond. And that's pretty much it. You can change anything else. So those, the four parameters that I said as underscore height and underscore width and x and y, they're also shown here because I put them in, I set the ask user true for those. And so you can actually change the location of your, where the pond is shown in, using, you can just change it by just dragging and resizing. And if you do, what you're going to see is, these values are basically changed accordingly. So now I have a different x and y, or we can actually change this by, I don't know, let's say I want to do it this way, so I can just move my pond by just typing the x and y value. Anyways, I can have another pond, so let's say add another pond. This is basically a name is automatically assigned to a pond when we create it, but you can also change it using just the name. So let's say this is I call it my pond 2. Okay, and this became my pond 2. Okay, so now okay, for my pond 2 I need to also assign some values. So let's say the bottom elevation of this one is 120, and the alpha coefficient for this one is I don't know, let's say it's 2.5, and let's say the initial storage in that my pond 2 is 50 as opposed to 100 for pond 1. Okay, so that's what we have. We can now save it. So let's just save it here. I don't know, just example. Okay, I'm going to save it as example in the same folder, and now we're ready to run it. So we're going to just run it. Simulation is done. Now let's just let's check some values. So I can just right click, and anything that I put in basically include in output is going to show up here. Maybe it was a good idea to also include storage, which I didn't. So basically now what we can see is that we can see the depth and the head. Of course, they're not going to change with time. Because these ponds are not really connected to anything and there's no inflow. So I can look at the depth here, and as you can see, the depth is constant. Its value is 4 point, I don't know, something between 4.472 to 725. Anyways, and I can look at the hydraulic head. So if I do head, it's the bottom elevation is 10, so the hydraulic head is just simply 10 plus that number. You can do the same thing for the second pond. That one. Now, if I want to also see the storage, all I have to do is, go and maybe, revise my my plugin. So basically, there is this thing called include in output, and I'm gonna put include in output here as well. And next time I use this, I use this, plugin, I'm gonna see the storage also will show in my output. And that's it for this video. I'll work on the second video that shows how to create a connector that maybe connects the two ponds or connect the pond to something else soon, and I'll post it on YouTube. Thank you.